is recursion and how do we implement it in C#. So if you follow the link in this article, or if you want to link in the below the video, there's a link to this article where I've got the example of code I'm about to write and a description of how it works and what is the difference between recursion and iteration. So recursion is a solution for programming in which applies itself to solve certain problems. Things we might have studied so far are things like merge sort, quick sort, both use recursive routines. They call themselves, and when they call themselves, they have to store the state of their program on the stack. So the problems with it is recursive routines can use a lot of memory. They can run out, and they can be quite computationally expensive to run. But in the case of merge sort and bubble sort, that it means that they could sort things much quicker, and they lend themselves to being used to recursively call themselves. And it simplifies the code a little bit, but it maybe is slightly more difficult to trace. So how are we going to code this? Right. Well, we've got to create a function, and we're going to call that function countdown, public static countdown. I'm going to take a parameter n, which is an integer. What you need in recursion is you need a base case to exit the recursive calling. Why do we need this? Because like with a while loop or a for loop, if there's not a condition which says now you need to stop looping, it will keep looping forever. So our base case is if n is less than or equal to 0, we're going to do console.writeLine. I'm going to print to the screen Blastoff. So we'll have counted down probably from 10 to 0. And then we're going to say Blastoff. But if that is not the case, else, we're going to first print console.writeLine. We're going to print n, so whatever it is, 10 and 9, 8, 7. But to then reduce the value of that n, we're going to call ourselves. So what is happening here when we call ourselves is we're going to pass an n minus 1. And so it's going to pass n minus 1 as a parameter into there. So it will call itself, check whether that's reached the base case. If it hasn't, it will print at the screen. So it will print 9, then call itself again with 8. Then it will check whether that's less than 0. It's not, prints 8. Then it reduces 8, reduces it by 1. So we get 7, passes 7 into that, and so on until we reach this base case where we get to 0, and then it will print Blastoff. Now, because there's no code that comes after this, nothing else will happen. So if you see, if I run this now, nothing's going to happen because I haven't called the function. So we need to call it countdown from here. We're going to pass in 10. And what's going to happen now is it's going to count down from 10 to 0 and then say Blastoff. And we give it a second. So what's really happening here, which I'll explain in a minute, is that the state of the program is being added to something called a call stack, and that is storing the last place that the function was called. Now, in this case, because there's no code after it, you don't notice any different. But you can see here we count down 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and then it reaches the base case Blastoff, and then the function will just end. However, if we put this print line statement here, something very different will happen. It will count up. It will say Blastoff first and then go from 0 to 1 to 10, because this bit here is not going to execute anything after it until this base case is reached. The computer will remember that it's got more lines of code to execute after that, and so it will come back to line 14 when with the last value that n was, which would have been 1, and then 2, and then 3, and then 4, and then 5, and 6. So if we just look at that on a spreadsheet here, so I've completed it before. I'm going to delete that. So we've got the values of n. Over that. We've got the value n. Is it less than 0? And then the last line number. So imagine we call 10. 10 gets passed into there. So n is 10. Is 10 less than 0? Is false. So the base case doesn't execute. So then we come into here. We call countdown n minus 1. So 10 is then taken 1 off 10. It's passed into there. So n becomes 9. This line doesn't get executed, but we need to remember that we have to come back to there with these values, right? It's false again. And we don't get past line 13. We take 1 off it to become 8, but we need to remember to come back to here to execute the rest of this function. And this is obviously going to be false up until we get 7, 6, 5, 4, 3, 2, 1. Blast n does not become Blastoff, but it will get printed to the screen. So n actually becomes 0, and then Blastoff is printed. And false is all the way here until n becomes 0. So it becomes true. 14 is here. But because it's true, line 11 gets executed. The rest of that function never gets executed. But the computer knows it's got more code it needs to finish. So it has to go back up the recursive stack. So starting here, it will go back to line 14 when n was 1 and print it out. Then it will go back to line 14 when n was 2 and print it out, and so on and so on and so on until it does what's called recursively unwinding, showing this Blastoff and then counting up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's because we moved one line. So if we have that before call, it will show the value of n as it was before it was called, which will start off at 10 and go down. But if we have it after, it will count back up. So that is what recursion is. Now, you can also write this. Maybe you should pause the video and have a go at this. Write this as an iterative function. So iteration is while loops, for loops. For loops. And anything you do recursively, you can do iteratively too. So simple solution to this bit would be this, and then I'm going to have a for loop for int I equals 0, whilst I is less than whilst I is great. Yeah, we're going to start off, and the counter is going to start off at n, right? Whilst I is greater than or equal to 0, because we're going to count down, right? And then we're going to take 1 off that. So this for loop is going to start at whatever number we give it. 10, for example, it's going to check to see that I is not 0, and then it's going to take 1 off it. And then we can do our console.write line, and we're going to print I like that. Countdown, and we're going to countdown iterative. This will do exactly the same thing, but it's just using a for loop. So maybe you can now try and write that with a while loop. Challenge yourself. Obviously, the last thing we need to write here is console.write line and then blast off. This is actually going to get to 0 and then say blast off. I run that now, you'll see what's happening. And it's just basically doing exactly the same thing as this function, although this function is a little bit more elegant, a little bit less code, whereas this one has a few more lines, and it goes from 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, and then blast off. But it basically does exactly the same thing. So you see, just by moving this one line here, we were maybe able to make it count up. If you wanted this now to count up, well, what would we need to change here? We'd need to start it. We need to change this for loop. We need to start it from 0 and check whether it was less than or equal to n, and then add 1 to it. So you'd have to change quite a little bit here. Whereas here, to make it do something opposite, we just need to change where the print line was. So that is recursion. And if you want to read more about it, look at the article on iCode Ben on here, where I've put the code, and I will link all the code in the article below as well. So thanks.